right now. I can do it for those of you who want me to do it right now. Sorry. So there is this. The first resistor is 100 ohm, and then basically there is a resistor in parallel, 200 and 100 ohm. I think the only problem that some of you may have is the way your book. I got this problem from Pearson. Draw the resistors. 150. So let me hide iClicker. And this one is. So on the exam, it will be drawn like this. I think it will be easier for many of you. And this one is 100. 100, 300, 150. Okay. So all of these are in series, right? So let me just say like that. So I'm gonna label this as R1. This is R2. Let's do R23 and then R4, R5, 6. So R is equal to R1 plus R23 plus R4 plus R56. Okay. If you want to see the solution, it's right there. This one is 100 ohm. We need to calculate R23. R4 is 150 ohm. And we need to calculate R46. So for R23, these two resistors are in parallel. So we have 1 over 200 plus 1 over 100 is equal to, so you need to know how to do this, okay? 3 divided by 200. And I have to take the inverse of the 1 over R23. So this one is 300 divided by 2 ohm. Okay. Similarly for R26, no, R5 and 6, it's 1 over 300 plus 1 over 100. Oh, I'm being sloppy again. I forgot to include the units. So if you want to include the unit, then you can put, I think it's cleaner without unit at the moment. Okay. So this one is basically 1 divided by 300 plus, if you want me to do it explicitly, and then I need to take the inverse of 1 over R56. Then it's 300 divided by 4 omega or ohm, then equal to which one? 200 over, okay, good, thank you. Thank you. Good. Any question? Sorry for the loss of connection. I'll try to post a video that cover the first 40 minutes of the lecture, of the review session. Because there will be similar problems to the problems that we did in the class on the exam. But the one that I will post in an hour only for the last 20 minutes of the review session. Okay. Any other question? So the answer is C. And make sure you're comfortable with right-hand rules, and the drawing will be on the exam. It will look something like this. This. And the exam will not cover the linear wire. This one, and there is still one problem on the study guide that involve magnetic field of a wire. I'll remove it. Okay. Magnetism. And then there is a series of problems that involve rotary motion. Make sure you're comfortable with that. So basically, if you have I think the drawing in our lecture notes is a vertical, as far as I remember. So first, so basically this is mass spectrometry. Basically, it involves one velocity filter. Basically, if you have particles with different velocity, you can expose it to a constant magnetic field. And then if you have electric field and magnetic fields, you can select a particle that has a definite speed. So the particle that exits the velocity filter will have the same speed. Okay. This is because in order to pass this opening or the slits, the force has to be equal to 0. So this is equal to QE plus Q times V times P. Q cancelled, and V simply E divided by B. This is just the absolute value. Is that clear? You need a known speed because depending on the charge per unit mass, the charge will go, okay, first, if you have a charge in, let's say, I don't remember exactly whether in the lecture notes, the field points towards you or away from you. Let's just pick this direction. Depending on the size of the mass and the size and the charge or the sign of the charge, the particle will either will undergo circular motion to the left or to the right. And the higher the force, the smaller the radius. So basically, this is from physics 111 for circular motion. The centripetal force is equal to the same here, and V cancels. So I think Q divided by M, that's the number that people want. Could be M divided by Q, but as far as I remember, Q divided by M. Charge per unit mass is equal to Q divided by M is equal to B times V Q divided by M. So we know V, we know the speed because we use speed filter or velocity filter. V is known, is the strength of the magnetic field that you apply. And radius is something that mass spec measure. Let's see what I provide you on the exam. Oh, absolutely nothing? Okay. All right. So I need to come up with an easier problem then. Okay, but there is a practice problem that involves mass spec on the study guide. Any other question? You can ask me about study guide also. Yeah, Sarah. I have to think about that, but I'll let you know ahead of time. And let me know whether you can access the exam, because right now, because your setting is different than my setting for Canvas. Right now, I set it to be available. Okay, let me make it more clear. My goal is to have you, it will be good if you can access this exam before Friday and let me know whether there is any equation that I missed. Okay. Is that good? Sorry for non-definite answer. But you can derive this equation, right? It's just one line. This is not like 3 pages of derivation. It's literally one line. And then if you want to solve for V, this is 2 lines. Okay, V. This is 2 lines. I basically subtract V, E divided by B for V. Any other question? So let's return to the, okay. So, and then there is a lecture on RC circuit. Okay. So let's do one last, well, 2 last iClicker questions. So let's say there is one nice problem that I found online. That is simple enough. Okay, so instead of using Q and C, they said, so initially you charge the capacitor with potential V naught, and then you connect the capacitor to resistance, and right now the switch is closed. The question is, what is the current that flows through the resistor or through the circuit? So the question is I. So I have 2 iClicker questions for you. Okay. The first one is, at this position, basically the switch is closed. No, it's open. Sorry. What is the current? Okay. Good. So 10 more seconds. 5, 3, 2, 1. Okay, good. So all of you got it right. When the switch is closed, is open, then the current is 0. So I promise you, this is the last iClicker question today. Now you close the switch. So what is the current? So it should be really easy for you. Okay. So there is a clicker question. 15 more seconds. 5 seconds. 3, 2, 1. Okay, I think it's pretty easy. The answer is A. Okay. And on Wednesday, we will continue with RC circuit. I'll see you on Wednesday. No. Okay. I'm sorry, I got your message, but I